All right.
Okay. Okay, so we chose this topic because we all really like rollerblading, and we thought it'd be pretty cool to learn about the average speed as we rollerbladed was. And we also wanted to find the comparison between the speeds of our rollerblades and a car, and a bunch of other things.
So the history of rollerblading. It's believed that rollerblading was first created in Scandinavia or Northern Europe to practice ice skating in the off-season. And the first documented prototype was made by John Joseph Merlin, but it had no stopping device and they weren't very comfortable, so it didn't work too well. And then in 1819, M. Pedalblad created a version of rollerblades that had a wooden platform, leather straps that would attach the rollerblades to the feet, and wheels that came in 3 different types that were wood, metal, or ivory, but there was still no brakes, so these still weren't very functional. And then continuing the history, there were many more attempts over the next 100 years, but they all lacked, all types of these rollerblades that were made during this time lacked comfort and efficient stopping mechanisms, so they still weren't safe or really usable. But then in the 50s and 60s, roller skating was really popular, but that's a lot different than rollerblading. And then the Chicago Skate Company produced a model of rollerblades that are much like today's in the 70s, but they still, like the brakes weren't too good. And then this was the type of skate that one of the 2 Olsen brothers found that, yes. So these, like the Chicago skate type, these rollerblades, as we know them, were invented in 1980 by 2 brothers. These 2 brothers were from Minnesota, Scott and Brennan Olsen. And Scott found that type of roller skate, a rollerblade, and he thought it would be perfect to fix it up and use it to practice hockey in the off season. So these 2 brothers, they began making the inline skates in their parents' basement, and soon other hockey players and people thought this was cool too, so they started making more, and they soon became a hit, but they still had their faults, and in 1983 they sold their company. And the new owner, Bob Nagel Jr., purchased the company, and he had a lot more money, so he was able to fix the problems with those, and so he put the brakes at the back of the rollerblade, and it made them more comfortable. This company became known as Rollerblade Incorporated, and that's how inline skates became known as rollerblades.
And this is just a video of kind of the history that goes along. It shows some pictures of what the first rollerblades looked like. It'd be kind of scary from some of these pictures, I think.
You can, is that speaker plugged into your computer?
Yeah, it's good.
Okay.
Alright, so how many of you have rollerbladed before? Lots of you. Okay, good. So one day we were all sitting around and we're like, our calc project's done. Rollerblading, we should do something. So we decided to go on one of our many rollerblading adventures, and it was really hot that day. It was like 80 degrees, so we're like, what sounds really good but a good ice cream cone? So we decided to rollerblade from my house down to the local Coburn store. and we thought that we'd be really good, but unfortunately we weren't as good as this guy.
Один. Представьте, пожалуйста.
He's like an old man too. We wish we were that good, but blading down to Coburn's wasn't that easy. All right. So the first thing we wanted to calculate was our average speed on our trip to the grocery store. So to find the velocity, we did some calculations, but Abby, or Michaela first, will give you some history on it.
Okay, so velocity is speed in a given direction, and it has ancient roots, but the part of velocity that we used was FTC Part 1, which describes the relationship between position, velocity, and acceleration, like how the derivative of the position function is velocity and the derivative of velocity is acceleration. And this FTC Part 1 was first published by James Gregory, and it was put in the form we know by Leibniz.
So to calculate average speed, it's distance divided by time. So from my house is 3 miles to Coburn's, and it took us 16 minutes and 37 seconds. So we converted the miles into meters and the minutes into seconds so that it was a more standard measurement. And we divided the distance, the total distance of 4,828 meters divided by the 997 seconds it took us. And that's about 4.8 meters per second. And when you calculate that into miles per hour, that's about 10.8 miles per hour. So now we're rollerblading along and we found our average speed, but we really wanted to know how much force we had on these bad boys. So we did another experiment to find out the force that we all had while we were skating.
Okay, so force is mass times acceleration, or mass times the derivative of velocity. And it's Newton's second law, and the history is Isaac Newton developed the law and calculus of the formula, and he published his book in 1689 where he formulated his laws of motion. And Leibniz in 1676 to 1689 developed the calculus with the notation of the derivative.
So to find the force, like Abby said, it's mass times acceleration. So to do this, we found the acceleration of Michaela for 20 meters. We timed her for 20 meters. And so the equation for acceleration in this case is 2 times the distance divided by the time squared. So it took her 5 seconds to go that 20 meters. And so we calculated that out, and her acceleration was 1.6 meters per second squared. And then we calculated her weight into kilograms and found her force to be 98.182 newtons. And to figure out how many newtons are equivalent to pounds, you multiply it by 0.22. And so we figured we have about 21.6 pounds of force when we are rollerblading. So we then were blading along, and Abby nudged me and she said, "You know, Colleen," she goes, "I'm pondering this really big question." I said, "What was it, Abby?" And she goes, "You know, our wheels are really tiny and those car wheels are really big, and I wonder how many times around our wheels go." So we measured our wheels, and we all have standard wheels, to calculate the circumference of how much area our blades travel in one rotation.
Okay, so circumference is pi times radius squared, and it's the linear distance around a circle. And the history is Archimedes wrote an article called Measurement of the Circle, and it is often referred to by most modern writers and mathematicians. And it was discovered that the ratio between the diameter of a circle and circumference was constant, and so they eventually found that it had to be more than 3, so then that's where it came from.
So the circumference of our wheel with this standard wheel size, the diameter is about 72 millimeters, so you multiply that by pi, and it's about 226.195 millimeters. So now she said, well, that's really small, but I wonder how far a car wheel can go in one rotation. So we compared how long or how many times our wheel had to go around to go a mile compared to how far or how many rotations a car wheel has to go around to travel 1 mile. So the diameter, like I said, or the circumference is 226 about for our wheels, and the circumference of a car, which was a Toyota Corolla, is about 1,356 millimeters. So in order to travel a mile, we took the circumference divided by, a mile, how many millimeters are in a mile, divided by the circumference of the wheel, and it takes about 7,000 rotations for one of our wheels to go a mile, and only 5 rotations for a car. So when you divide that out, our wheels are going 1,000, it must have been 1,356 more times than a car wheel to get a mile. So then we get to Coburn's, we're eating our ice cream and we're headed back, and like I said, it was a really hot day. So we're chugging along this 3-mile trek, and Michaela nudges me and she goes, oh my gosh, oh my gosh, oh my gosh. And I'm like, what's up, Michaela? And she goes, my ice cream is dripping through the bottom of my cone onto my new rollerblades. And I was like, that is not okay. So we decided to do some more math and figure out the rate at which the height in her melting cone was decreasing at certain points. So
The history of related rates, they were first published in text in 1836 in a book by Reverend William Ritchie. It was called Principles of Differential and Integral Calculus. And he was a teacher at London University, and he wanted to reform calculus to make it so that everyone could understand it and not just students in calculus. And related rates appeared again in 1841, and there were more problems by James Connell. And he wanted to explain more of the purpose of calculus, and related rates helped show how it was usable in everyday life. And then that was also in Europe, and so related rates first appeared in the US in 1851 in books by Elias Loomis, and there were 10 problems in his books, and 9 out of 10 of these problems were problems of Reverend William Ritchie, but the one that he came up with himself was the one where the base is changing in a cone and the height remains constant. And in 1877 began related rates as we now know them.
So to do this, we wanted to calculate it at 2 different points. So when the ice cream was melted 3 inches from the top of the cone and melted an inch. So our basic information, we realized that the ice cream was dropping at a rate of 1/8 of an inch per minute, and that using similar triangles, we found our volume, or our radius, to put into our volume equation, and we took the derivative of our volume equation. So the first one, we wanted to find how fast the ice cream was draining when the level was 3 inches high. So we plugged it into our derivative formula, and we found that it was dripping at the height of 0.022 inches per minute. So that's how fast the height was going down at 3 inches high. And then we did it again for when it was just an inch below the surface, and we found that it was dropping at a height of 0.199 of an inch per minute at that rate. So this is what Michaela was experiencing when her ice cream was melting.
And so, since we got ice cream, we thought you guys should get ice cream too. So,
Thank you very much.
I know.
I took them off, so
What are you gonna do? Give us all picture of these? If it helps, did everybody get one? My copy is pretty good.
Okay.
Sometimes I feel like watching it though.
So, after this long and hot trek, and as Michaela was pretty messy with her ice cream cone dripping, but we got back, and I said, you know what, this was just not good. It was too hot, the roads are too rough, there wasn't enough sidewalks, and that hill was a killer. So, I had this great idea to drain the pond in my backyard and fill it with concrete so that we had our own roller skating rink.
okay, so the history of volume is Greek mathematicians of last centuries before the Common Era found theory of volume calculations from empirical rules, and Archimedes was one mathematician that found exact rules to find volume for round solids in the 3rd century BC.
So to do this project, we found the volume of our pond, but we didn't know the exact dimensions because it's a pretty big pond. So we hired this guy to take an aerial shot of my pond, and he came back with this diagram, and yes, my pond is a little funny shaped. But he also informed us that 1 unit on his graph was about 100 meters. So to find the surface area, we took the top curve minus the bottom curve, and we multiplied it by the height, which he told us was about 3 minus x. We found it to be approximately 836.9 meters cubed, which when you, 1 meter cubed is about 264 gallons. So the pond held about 221 gallons of water. So in order to do this, we had to go to my dad and all of our parents and get some approval, and well, that didn't go so great, but here are some shots of some people doing some pretty cool things on another roller skating rink. This is what we wanted it to be like, but it never really happened that way. Alright, so then after calculating all of our stuff, we also found some other applications of what math we used.
Okay, so speed is used for cars, bikes, and trains, and taxis, and other stuff that moves. And force, we use the force formula, force equals mass times acceleration in physics class. Also define the force of a roller coaster.
Circumference is actually an everyday example is the waist size of your jeans. It gives the circumference around your body, same with belts. Related rates are also used a lot, but you have to find the mathematics for this. But they're used for finding rates at which water is pumped, that silos are filled, and they're used to find how fast ice melts, among other things like that.
And our final one, volume. Volume is used for the max volume of a pan when you're baking, how much water a water bottle can hold, pools and bowls. And in addition, it can help find how much material such as concrete is needed for a job, just like how we need to find how much volume was in our pond so that we know how much concrete we needed. And that's it. That's our presentation.